Riley Hasenstab. This is my Lab 4 on bar magnets. So table of contents, so the introduction, data and observations, code, discussion, conclusion. Introduction, we got purpose and fundamental principles. The purpose of the lab is to see the influence of magnetic field from a bar magnet and predict how this influences different observation points using the Biot-Savart law. And a quick preview of the results. Bar magnets have a magnetic dipole which moves objects in the direction from south to north on the parallel axis and north to south on the perpendicular axis. So this law acts as a relation between magnetic fields and the current of the source, seeing how charge and density and distribution influences the force on the surrounding points of observation. And the equation, which is to the right, can be altered. So we have the magnetic field is equal to the dipole times 2u divided by 4 pi, and z cubed, and this is current times area for the dipole. And so that's the equation that we'll use later in the lab. Experimental model. So this is the model we had in class, the phone with the app, and that's kind of the initial condition would be the app and having the magnet and setting up the yardstick. So the system would be the phone and the app, surroundings, the bar magnet, and then the table, I guess. And magnetic field of the earth should also be considered. And then if any electronics were around, but we tried to remove electronics from the area so they wouldn't affect the magnetic field. So here's the sensor. The sensor first needed to be zeroed out on the phone, and we used like tape to do that. So the north-south axis and then the east-west axis, tape the phone and the meter stick where both are zeroed to make sure the influence of magnetic field is zero of the phone. And this was some on-axis data we got. So that was over here in the Excel sheet, and then this is the graph we got. And so this equation we used, so that was our data, and that equation we used over here. And originally when we did the calculation, the y-axis, or the b value was messing up. So we kind of plugged in this one to make the results more realistic. And we found the magnetic dipole moment to be 3.365. Yeah. And we just worked around that equation, and then we solved for the magnetic dipole moment. And then this is some off-axis data. Yeah, from the Excel sheet. I just wanted to include it in the lab because it was data we got from the app. Some observations. When the magnetometer is far away from the magnet, it measures near zero magnetic field in that direction. Yes. As the magnetometer moves closer to the magnet, the measured x component of the magnetic field decreases. No. The position of the magnetometer had no effect on the measured x component of the magnetic field. No. As the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. Yes. So this was the GlowScript code. Here we make the dipole definition that was given, the dipole B, to find that dipole moment, and you set the equation for the constant, calculate the values on or off the axis, and we have these vectors here, and then another dipole B, and then this is right here is to make the model, which is on the next slide here. And we have the model, and that just shows the arrows and these values, B perp, distance, and the degrees. So assumptions and sources of error. Assumptions: bar magnet acted as a magnetic dipole. Magnetic field of Earth was ignored computationally. Sources of error: other objects in the surroundings creating magnetic fields. Location of the magnetometer on the phone may have not been precise, or human error when measuring distance or magnetic field. So what if you hadn't oriented your experiment to compensate for magnetic north and then instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? The components of the magnetic field would have been measured as off by a little, since the Earth's magnetic field would have influenced them. And what if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? The experiment would be the same, but the magnitude of the forces would increase by a certain magnitude. Thank you.